Hello. Yes, we welcome you back to PSSB, Physical Sciences Silver Bullet, with me, Richard, here. Today we are looking at this question. It says that what is meant by one dimension motion? Yeah, what is it? Yeah, one dimension motion is the motion in a straight line, which we call rectilinear motion. Yeah. Then we come to this question. It says that define distance. Yeah, what is it? Yeah, distance is the length between 2 points, and it's a scalar quantity. Yeah, that is that. Yeah, then comes another question. It says that define displacement. And what is it? Displacement is the distance moved in a particular direction. Yeah, then we come to this question. It says that the diagram below shows the position of Daphne's home, school, and the netball field. So these are the positions and their respective distances. And then they say Daphne moved straight to school. After school, she went to the field for a netball game before going home. Okay, that's how Daphne moved. And here they say, at the school, calculate the distance Daphne has covered. So this is what we are having. They said Daphne moved straight to school. So what is the distance covered by Daphne? Okay, this is the map. She moved past the field and then reached the school. So what is that distance? The distance is going to be 80 plus 50, giving you 130 meters. Yeah, that's the distance Daphne covered. Yeah, then we come to this question. It says that calculate displacement Daphne covered. Remember when Daphne is at school. Okay, how do we go about that? Okay, you have to know that what we call displacement in the simplest terms is the shortest distance between the original point and the final point. So this is home, yes, which is the origin point of reference. And this is the school. That's where Daphne is at the moment. So what is the shortest distance between the two? It is going to be displacement, which you normally call delta x, is going to be equal to 80 plus 50, giving us 130 meters. Yeah, that is it. So in this case, distance is the same as displacement. Yeah, then we come to the question, calculating the total distance covered. Okay, so how do we go about this? This is what you have to know, that Daphne moved from home passed the netball field and reached school. That's straight to school. In that way, he covered these distances. Then she moved from school to the netball field. So what is the total distance covered? It's going to be 80, okay, plus 50, 80 plus 50 to reach school. Then she moved from school to the netball field. That's 50, giving us a total of 180 meters. Yeah, that's the total distance covered by Daphne. Yeah, then we come to this one, the total displacement. And what is it? Okay, displacement, which is delta x here, is supposed to be the shortest distance between the initial point and the final point. We need to recall that she moved straight to school and then came back to the netball field. So, which means that our displacement now is from the field to home. And how do we get it? Let's follow the movement. She moved 80, you have it here. Okay. She moved 50, we have it here. Okay. Then she came back. Coming back means moving in opposite direction. So displacement is minus 50. Giving us what? 80 meters. Yeah, that is what happened. And 80, because displacement is a vector, is positive, which means it is to the right of the initial position. Yeah, then we come to this question. It says that calculate each of the following after Daphne comes back home. Okay, the first one is total distance covered. Yeah, what is the total distance covered after Daphne comes back home? Okay, yeah, we are going to say D is equal to, let us start. She moved 80. Okay. Passed the field up to the school, that's 50. Okay. From school to the netball field, that's 50. And from netball field to home, that's 80. Yes, that's the total Daphne covered. And when you add, what do we get? We get 260 meters. Yeah, then we come to this one, total displacement covered. Okay, so what is it? This is what we know, that displacement, which is delta x, is equal to Daphne moving, passing the field, which is 80. It is positive 80 because it's to the right. We took the right to be positive. Then for our passing the field up to the school, that's another 50. Then from the school, passing the netball, that is negative 50. Then from netball field up to the home, that is negative 80, giving you 0 meters. So the total displacement covered when Daphne moved the school and come back home is 0. You have to remember that the simplest way of understanding displacement, it should be the shortest distance between the initial point and the final point. But in this case, our initial point and the final point are the same. And with that, I would like to thank you for your time. The channel is PSSB, Physical Sciences Silver Bullet, with me, Richard, here. I would urge you to subscribe, to comment, to like, to share. Yes, we believe we are simply the best. See you next time. Bye bye.